As we know, the stack is a data structure that emphasizes first in, last out, or analogously speaking, is the last element to get pushed into the stack will be the very first one to get out. In this implementation, we're going to use the stack implementation using an array. Remember that a stack can be implemented in both ways, using an array and a linked list. We're going to use an array of strings as a way to illustrate the stack of the array. Remember that the top will be the index that will point to the top of the stack. These are the two most important items in the data structure stack A. Make sure you have a constructor to initialize these items. By convention, the stack has a capacity of 10. That is the convention that most of the data structures that require an array's base are initialized to. And top will be 0. The stack has three main methods: the push, the peek, and the pop. Let's start with push. Push will take a string x as the element that we would like to add to the stack, particularly in the top of the stack. The method is a public method with void, meaning that there is nothing that we're going to return back. We're only going to add it to the stack. The question is, where are we going to store it? As we know, stack right now will be stored element x at position top. Remember that the stack has first in, last out element, and the top of the stack will indicate the position where the element is going to be stored. Now remember that at the very beginning, when the stack is empty, we can just add it at position 0. But once we add it, we need to update our top. The next element is peek. Peek does not take any parameter. However, the signature of the peek is to return an element that is in the current position of top. In other words, whatever is on top of the stack, that's what we're gonna return, but not remove. So it's kind of safe to say that we're gonna return whatever is in stack at position top. Is it? Not really. Remember that in push, we add 1 after we add it. So in case you want to retrieve whatever is in top of the stack, we need to say top minus 1 because we already prepared on line 10 for the next time we push another element to add it at that position. You probably have seen different implementations of the push and the pop depending on the authors. But by convention, we usually add them and then we increase the capacity as we did. Pop, however, is different. Pop will also returns a string and does not take any parameter. Similar as peek, we're going to return top at position minus 1, but be careful. Pop does really remove the element that is there. So what we recommend to do is to create a temporary variable that will hold the value that is at position top minus 1, then decrease the value of top, and then return the value of temp. These are the three methods for stack are implemented by the array. Let's test them. The first thing we're going to do is to create stack A object. I'm going to call it S for stack, and I'm going to create a new stack implemented by the array. That's where the A comes from. Now we're going to add a couple of elements to the stack. Shall we? Let's push some strings. I'm using a new version of code. Code has this automatically X put here as the name of the parameters. Some of my students ask me often, it's like, how can I put this X colon? You can do that thing, but this is an automatic definer from code. Notice that X, if we go back to stack A, that is the name of our parameter. So that only indicates for you to say, this is the value that the argument X will take place in the main as the name of the parameter in the class stack A. Now, let's go ahead and peek to see what's on top of the stack. Remember, peek only retrieves whatever is on top of the stack, does not remove it. So we expect the string D, because D is the last element to get pushed into the stack. Let's save, compile, and run this program. As you can see, we got D, because that's the last element to get pushed. How about if it's pop? Let's system out println s.pop. What are we expecting from here? Well, we're going to retrieve whatever is on line 8, the top of the stack, which happens to be D because that's the last element to get pushed. On line 9, we're not only going to retrieve it, we're going to remove it. So we're going to return also D, representing the last element from the stack. Let's peek after that. If we peek after the pop, we expect C because that's the next element from the top. Let's save, compile, and run this program. There it is. We have B coming from line 8, then we have B coming from line 9. Then we have C from line 10 because we're just retrieving whatever is in that position on the top of the stack. Check this out. What happens if I pop 1, 2, and 3 times? Well, we're gonna have obviously line 11 is C, line 12 will be B, and line 13 will be A, correct? Let's save, compile, and run. Excellent. We got those values. So the question is, what happened if we try to pop that position on line 14? Let's save, compile, and run this program. Array index out of bounds exception. That means that we went to index -1 in order to access them. We need to handle this situation properly. And the best way to do it is by going to the stack array. And notice that the pop here, before we arrive to that position, we need to check. If the top happens to be 0, then we need to throw a new stack empty exception. The stack is empty. Now notice that we're creating stack empty exception. We need to make sure we throw that item also as part of the signature of the pop. But what is a stack empty exception, Professor? Well, we have to create it. And you already know how to do this. By extends exception, the superclass for throwable. So in the constructor, we only need a string as a parameter and call the super constructor S. You can save this in the same directory. And remember, when we come here to the stack tester, we need to use a try and a catch that will handle the exception. Let's save, compile, and run the program. There it is. Notice that now we don't crash the program, but instead we handle the situation and we just print the stack is empty. Now, similarly, that piece of code should be identical not only on pop, but also on peek. Because remember, both of them, you access the top when it's empty. Analogously, when we have a push, we also need to handle that situation in case we go beyond position 9 in order to avoid the stack overflow exception. So the easy thing to do is to have an exception to say stack empty and change it by stack full exception when top is stack.length. That means that is full. You're welcome to do this. However, let me have your attention here. Why you have to complain and crash your program where you can find a solution? Instead of throwing an exception, why don't you expand the capacity by calling a method ensure capacity? Ensure capacity is a private method that only shall be accessed by this class. And the purpose of this is to create another stack with the current capacity of the stack, that length, times 2. Pretty much what we do is that we're gonna double up. We're gonna double its size, the capacity of the current stack, in order to provide a bigger array. The next step is to migrate everything from the old stack to the new stack, like this. Pretty much what we're doing on line 12 and 13 is to migrate whatever is in the old stack to the new stack. But we're not done yet. Just before you leave this method, what is necessary is to point that stack is now the new stack. We're using a reference only. Reference for the location of the new stack now will point where the stack is. It's a beautiful solution in order to avoid a full stack exception. We can test this by pushing more values. Notice while I introduced K will give us an array index out of bounds. But this time we have ensure capacity, so there is no need to have that exception. Let's save, compile, and run this program. You see, nothing happened.